Custom type in C++, struct, class, union. These are the tools that you can use to create a customized type um, in C++. Let me jump into the coding to explain it. The topic here is custom types. So if you want to store or if you want to package information related to one particular thing, for example, if you talk about um, house, it may have a different attributes in it. It may have different features of it. One can be, let's say, height, right? It can be um, color. It can be name. So if you have this different kind of attributes to packaged in a single entity, and if you want to have that kind of data type and store this kind of information in the object of that data type or variable of that data type, you can create a custom type. And there are three custom types you can create. One is struct, another is class, another is union. So I will talk all one by one. First, let me uh, have an example where a convenient example here would be a student. And we assume that student have ID, whole number, and expenses, uh, double type. So in this case, I want to have one student object and some type here. So I want to be able to store ID into it, and I want to be able to store uh, expenses like this. So you need to create a type, and the type you can create for this in this situation. You can use a struct to do that. The syntax for creating type struct type is you use a keyword struct followed by the name of the student, name of the type. Let me call it student. Now this thing here is the name of the type, like integer, int, double, like that. And you put the members in it. ID, I want to store whole number, so it will be integer type, and expenses, and I want to store the fractional part as well, so it's going to be double type. Now this is the one custom type, and just remember, either you create struct, class, union, you need to put semicolon at the end of this thing. This is called the definition of this type, definition of a student. So now I can create a student object by putting the type information here. Right now this statement becomes the statement for creating a student object. This is it is like variables, but the convention is that in this custom type we call this thing as a object instead of the variable. So and student has a member ID, so we store this data in the ID and this amount in the expenses. Now you can access that information using this syntax. I mean the same syntax we have used to set the data into. Expenses, let me jump to the terminal and execute and see the output. Now you can see the ID 11001, expenses 2222.22. So this is we have created a type, stock type. You can create like this, and it is helpful. Sometimes a student may have a lot of different information, so you can package all everything together. And it's also possible that you can create an array of this type to store 100 information. For example, if you want to store information of all the student in a class, then you can create an array, and you can access first element using this syntax id, right. You can set another data in the second element of this student array. Similarly, it's also possible you can create a pointer out of this type, and you can make this pointer point to the first element, similar to what I have done in the previous video when explaining the array. If you have not watched, I encourage you to watch that video. So now you can iterate in a loop. Say I want to store information of 3 students, and I want to put a prompt, enter ID and expenses. I want to write that user entered ID and expenses into an element through the pointer. So it's going to be SPTR ID, because this is a pointer, so you can use this syntax, and also SPTR expenses. But there is one twist here. If you do like this, it will always access the first element of the array and keep storing in the first element. If you want to keep, each iteration, if you want to store data in different elements, then you can do kind of incrementing of the pointer using this syntax. Now we'll have after the execution of this loop, we'll have the information information of 3 students stored in the 3 elements of this array, because this pointer is pointing to this array, so it will have access to the 3 elements of the array. Let me display the content of the array after this. And I equals to 0, I less than 3, I plus plus. And I want to actually display directly from the array itself instead of through the pointer. Sti dot id expenses, and display in different line. Let me put id text here. Let me compile this code, quickly see the output, and I'll come back discuss it further. Execute. Now it is asking me to enter the ID. I'm entering 2001 and expenses 2222.22, 2002. This is for second student 3333.33, 2003 4444.44. Now it was copied because copying was carried out through the pointer. Now it was displayed in this line. Displaying was actually carried out by using the name of the array itself. And also you can use a reference. For example, if I want to create reference to this student, then I can create a reference with this type, sref equals to, let's say, a student. Then I can display id. The syntax for accessing the elements is similar to the way we have done here. I think I could just copy this and use it here, and only change this name of the object as ref. So this should display the same data here, because this is just a reference to this student object. I think it's asking me 1G0. So let me have 3G03, 4G004, 5005, 555.55. Now we are interested in this thing, right? So this was actually displayed through the reference, and this was displayed through the object itself. Now this is about the structure, and you can also create class. Right? If you want to create a class, you can use the keyword class that in the way that I used. Class is a little bit, I mean, in C++ compared to C, I mean, struct and class have a slight difference. They are more or less similar, but one basic difference here is these things are actually public by default in structure. Therefore, we are able to access from other code. But in the case of class, we cannot do that because these are private. So if I create the object, professor object, I will not be able to do that. So I will need to create either, I mean, explicitly declare these things as public, or I will have to have some other functions like constructor and those things that I'm going to discuss in the future other videos. So I'm not discussing further with, but one thing I want to mention here is that this is a syntax which creates a type. Professor is a type, like in the case of a student, and if there are proper the functions that are actually put in this class, you can actually set the data to it, you can display the data to it, and so on and so forth. So this is a class, and also you can create a union. Give the name. So union is kind of similar. You can have same members like in the struct here, but the difference here is these things are public by default, like in the case of a struct, but the difference is that it will actually use the same memory space to store both data in ID and expenses. So when you put ID, it will copy ID into the same place, and when you I mean set the expenses of the object, it will, I mean, overwrite that space to store the expenses, right? So it looks like, I'll quickly, I mean, explain it, but I mean, I will not be experimenting in detail here. You can create a union object using this syntax. This is my union type, and then the object name, and mu equals to, let's say, mu.id equals to 2G02. Then it will write, it will have same 8-byte memory space allocated for both members, and it will write 2G02 as integer in that memory space. And then if you write expenses, then it will overwrite the same memory space and store this information as a double information. So it doesn't make sense to try to read expenses if ID is stored there, and also it doesn't make sense to try to read ID if expenses is stored there. So there should be a mechanism of mechanism to track which member is being currently used. So that is a little bit complicated, but in some cases it is this is a type which is pretty useful.